Williams class. For your maths lesson today, the arithmetic is as follows. 5 times 7. What is 18 shared into 3? What is 823 as a Roman numeral? What number is next in the sequence? 1, 2, 3, 5, 7, 11. 9 times 9. 32 divided by 8. What is 3 kilometers in meters? 6,788 plus 2,231. 9,875 take away 2,462. 42 divided by 7. Pause the video, and when you unpause, we will go through the answers. Here are your answers. 5 times 7 equals 35. What is 18 shared into 3? 6. What is 823 as a Roman numeral? D, C, 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 X, X, I, I. What number is next in the sequence? 1, 2, 3, 5, 7, 11, 15. 9 times 9 equals 81. 32 divided by 8 equals 4. What is 3 kilometers in meters? The answer is 3,000 meters. 6,788 plus 2,231 equals 9,019. 9,875 take away 2,462 equals 7,413. 42 divided by 7 equals 6. Now, our learning objective for today's maths lesson is, can I understand what a tenth is? Quick challenge for you. Here we have a number, 4,369. Now you have 3 questions. Number 1, what does each digit represent? Number 2, can you rearrange the digits to make the smallest and largest number? And number 3, can you make it an even number? So when you rearrange the numbers, can you make a number that is even? Right, let's get started with the lesson. All numbers have a decimal point. Now, a decimal point is a huge, well, not huge, but it is like a full stop, and it never moves. We only show it when we have numbers that are not whole. So, for example, if you have the number 10, 10 is a whole number. 10.5 is not a whole number. So you then see that decimal point with me saying point. The first number after the decimal point is called a tenth. So I'll show you an example of a number here, 123.5. So the number that is called a tenth is in fact this number over here. This would be our tenth, and that's how you identify it. So tenths are fractions that always have 10 parts. So for example, for this question here, we have 3 parts to this question. As you can see, we have yellow counters, red counters, and green counters. So just to help us, I'm going to first count how many counters we have all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all together, 10 counters. Now, how many of the counters are yellow? So look at the yellow counters. 1, 2, 3. So we have to write this as a fraction. So how would you write that 3 out of 10 of the counters are yellow? Think back to your fraction knowledge. It would look like that. And instead of saying 3 out of 10 of the counters are yellow, because that is quite a mouthful, you can just say 3/10 of the counters are yellow. Next one, how many of the counters are red? So let's count how many red counters we have. 1, 2, 3, 4, 5, 6. Show me how you would write that as a fraction. Good. And now how would you say this fraction? You cannot say 6 out of 10. It would be 6/10. Well done. And lastly, how many of the counters are green? 1. Easy peasy. How would you write this as a fraction? Good. And how would you say this as a fraction? 1/10. Fantastic. Now we can use part-whole models to help with fractions. Here we have one whole that has been divided into 10 parts. So if in one of those parts we have 3/10, 3 out of 10, what number do you think would go here? Have a little think. Or not even number, what fraction do you think would go there? If 3/10 is here, what would go here? If you said, or even if you were writing this, if you wrote 7 out of 10, you would be correct. Because how I like to think about it is, I like to pretend that there's an imaginary 0 here, and I want to make sure that this number and this number add up to give me 10. And you can test it by doing 3 plus 7. So if I have 3 here, I'm going to add 7. 1, 2, 3, 4, 5, 6, 7. And you have 10. So this could be a tricky method to get your head around, but bear with me here. You are just getting introduced to tenths, so it's okay if you're finding it a little bit tricky. You're doing really, really well so far. Now, your turn. Try answering these questions. The first one says to tick the pictures that show tenths. And then your second question is about filling in the part-whole model with what you think goes here. Off you go. Let's go through these together. So the first question says, tick the pictures that show tenths. Which pictures do you have to tick? I'll give you a clue. How many parts should those pictures that you tick have if they're trying to show tenths? They should have 10 parts. So let's see then. Let's see this first shape here. Let's count the parts and see if we have 10 parts in total. If you have less than 10 or more than 10, then they are not a picture. They would not be a picture that shows tenths. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This picture does show 10, so I would tick that. Let's try this picture here now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This picture also has 10 parts, so I would tick that because that is a picture that shows tenths. Next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no, that does not show tenths. That has 12 parts, so it would not be a picture that shows tenths, so I'm not going to tick that. Let's try this circular picture here. 1, 2, 3, 4, 5, 6, 7, 8. This would not be a picture that shows tenths either because it only has 8 parts. Let's try this one with the flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a picture that shows tenths. What about this last picture here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This also shows tenths because it is divided into 10 parts. So very well done if you have correctly identified those pictures. Next one here, we have our whole number 1. Now in one part whole model, we have divided, or we've put 7/10. So what would go here? Remember, there's an imaginary little 0 at the end. So what number would you have to add 7 to get 10? 3. So the fraction you would put here is 3 out of 10, also known as 3/10. Now, your independent task for today is here. Number 1, Amir has some blue and yellow cubes. He makes a tower using 10 cubes. Now, investigate how many different towers Amir can make with 10 cubes if every tower has a different fraction of blue and yellow cubes. So, in this tower here, Amir, I've drawn that cube terribly. Amir has made a tower using blue and yellow cubes, hasn't he? You can see that very clearly. In this tower, he's used 2 yellow cubes at the top, and he's used 8 blue cubes at the bottom. So what this question is asking you to do is to figure out how many different towers Amir can make with these 10 cubes, and you can have a different fraction of blue and yellow cubes. So for example, I think he could make a tower that has 8 yellow cubes and 2 blue cubes. So I would write, rather than writing that, I would write in brackets 8, not blue, I would write 8 yellow, hang on. Because it's just asking you how many different types of towers can Amir make if he has 10 cubes using blue and yellow cubes. Not necessarily just 2 yellow and 8 blue, but he can have any amount of those blue and yellows. So that's why I'm writing he could make a tower with 8 yellow cubes. And then how many would he need to add? How many blue cubes would he need to add to make 10 cubes altogether? If you have 8 already? 2. So he would then add 2 blue cubes. So that is one example of a different tower that he could make using 10 cubes. I would like for you to come up with at least 2 more. Off you go. Next question here. Danny has a bag of sweets. Now, half of the sweets are red. 3/10 of the sweets are yellow. The rest are green. So what fraction of the sweets are green? Have a go. So half of the sweets are red. 3/10 of the sweets are yellow. The rest are green. What fraction of the sweets are green? If you said 2/10 of the sweets are green, you are correct. Well done. Next question. Mo also has a bag of sweets. 4/10 of his sweets are red. Now the rest are green or yellow. Now what fraction of Mo's sweets could be green and what fraction could be yellow? So have a little think. If he has, let's say, 10 sweets in total, doesn't he? 4 of them are red. So how many can be green? How many can be yellow? There are 2 answers to give here. Have a go. If I was to answer this question, there is more than one answer. So that is why I'm saying if I was to answer, one possibility that I found, which you may have found also, is he could have had 2/10 of his sweets being green. And then how many could be yellow? Now, the way to write this out is he's told us 4/10 are red. 2/10, I've told you, could be green. Now, what's 4 plus 2? 6. So we've already identified 6 of those 10 sweets. So the number that is left over would then be how many sweets, would then be the amount of yellow sweets. So how much do we need to add to 6 to get to 10? It would be 4. So 4/10 could be yellow. So that means then, out of a possibility of 10 sweets, or out of a total of 10 sweets, he has 10 sweets in his bag, 4 could be red, 2 could be green, and 4 could be yellow. And if you test that out, if you count those all together, then you will figure out that you've actually labeled each of those sweets. So you've managed to tell me what the color of each sweet is. Now, how many possible answers can you find? I would like for you to now tell me, if you didn't say that 2 of the sweets could be green, what number do you think would belong to the color green for the sweets? And how many sweets could be yellow? Or how many sweets would you say are yellow in Mo's bag of sweets? So it really does depend on the way that you're thinking about this question. There is more than one answer to this, so I'm excited to see what answers you come up with. That is all for our maths lesson for today, boys and girls. Now, it was a fairly tricky lesson, I'm not going to lie. Fractions, not an easy topic, but the fact that you are already here listening and wanting to know more about it is excellent. And this is not the last time that we are going over fractions, of course. So we will get more opportunities to discuss this together. But for now, that is the end of your maths lesson, and I will see you very, very soon in the next video, Williams class. Bye.